Okay, so this question says that a cancer research group has surveyed a random sample of 500 women that are over 40 years old. And they're looking at the hypothesis that 28% of women in this age group have regularly scheduled mammograms. So out of these 500 women, they say 151 said, yes, we have regularly scheduled mammograms. It's where you get an image of your breasts for breast cancer. An ultrasound. Okay. Yes. Read more stuff. So read more. Just just read more things. Okay? Read more things. Okay. Download the Associated Press app on your phone. Just start reading. Just start reading.
The
Associated Press. And just start reading. It's just a way to get news that's not partisan. Just read.
That's what Twitter's for.
No, that's not what Twitter is for. Oh, sweet Jesus. Okay. So they want to know, is this enough evidence to dispute the 28% claim? All right, so let's do the parameter first. All right, so I'll be looking for this sentence first tomorrow when I grade your quiz. All right, define the parameter. I will grade it tomorrow. Okay. Define the parameter. Well, you don't need to write this. Just tell you what I'm going to do. All right, you don't have to write define the parameter. You should just define it. All right. So let P represent the proportion. Okay. Of all women, be a little bit more specific. Before that, all women. There you go. Over 40. Who? Very good. Regularly. And I'm not a woman over 40, but I believe it's every year. But I could be wrong. No. So while there's a lot of factors there with your family history, I think if you had no family history of breast cancer, I'd have to Google this. But I think it's when you're 40 is when you start. Right? But if you have so my wife has a friend whose mom died of breast cancer, and so she started going at 25 to get mammograms. It is very scary.
Is that evidence that getting a mammogram gets you?
No, the idea is to catch it early, right? So if you catch it before it's metastasized or spread farther, then you have a better chance of surviving. So that's why you get regular checks. Not you, most likely. You're not a woman over 40, but men have other things that we have to check for. Prostate.
I love those.
Sure you're not getting those checks yet. Who get regularly scheduled mammograms. Thanks for that, Wences. My peripherals will never unsee that. Okay. So that's the first statement. Define the parameter. Please, in context. Right? If you just put, let P represent the population proportion, you're not going to get full credit. Okay? So please, in context. Do your best. And what I always tell students is use the problem to help you. Right? A lot of these words that I wrote were just ripped straight from the problem. Okay? Or that word I can't use were copied from the problem. There we go. No, that's not okay. We're regurgitated from the problem. I don't know what to say, Bianca. Okay, there's so many limitations. Okay, so now we're ready for the model. Okay, I'm not going to do this part, right? But you have to. So tomorrow, what assumptions are you making? Independence and the sample size assumption. So make sure you know the statements to write for independence assumption and then the sample size assumption. So I'll just put you have your independence assumption and your sample size assumption. Right? And I want a statement for each, please. All right, so one sentence for each. Then you have conditions to check. You have the randomization condition, and you have the 10% condition, and a statement there for each. And then finally, the success and failure condition. That one I expect to see some work. All right, if you remember back from Tuesday, right? Remember at the end of the day when we did the whole long problem on Tuesday, this is where you're going to do N times P and n times q. And you're not just going to pull these numbers from the problem. You're going to take p, which we think right now is 28%. All right, and do 500. I'll write this one down. Well, I'm not going to if this doesn't work. There you go. 500 times 0.28. All right, so does everyone see how I'm not using 151? Okay, so that's a key thing I'll be checking for on your quiz tomorrow. The successes, even though that is our number of successes, when you check here this condition, please use what you think P is and what your sample size is, right? So that's why we multiplied here. All right, so this would be 500 times 0.72. Okay? All right, and I'm stopping here, but you would get those numbers. All right, and then say the statement, they're both 10 or higher, or they're both above 10. Okay? Everybody good? Yes, yeah.
You have to say that statement in 5. That's fine.
Yes, I'm about to say that statement. Yes, Leslie. Did I not do that already?
No.
Oh man, I'm so sorry. Yes, I would have already done that. I'm so sorry. So let's do this. So like this is going to be after my hypotheses. I'm sorry about that, Leslie. Thank you. All right, so I'm going to do my hypotheses out of order. Let's finish the model since we had already, Bianchi brought it up, and then I'll do the hypotheses. So the statement at the end is the conditions have been satisfied. So I'm going to use the normal model to run a 1 proportion z-test. And that one you can just book, right? That one, just copy it exactly like that. Okay? And that statement we wrote on Tuesday. All right? Okay, so the hypotheses. Thank you, Leslie. So the null hypothesis. What do we think P is right now? Very good, 28.28. All right, so we think the rate of women 40 or older who are getting regularly scheduled mammograms is 28%. What are we trying to prove? All right, let's go to the problem. Okay, does it say something about being greater than or more than? It says lower. Where does it say lower, Jonas? No, I'm just asking. Do you see where it says lower? Oh, wrong problem. So it doesn't say anything about higher or lower. It just says to dispute it, right? And dispute it just means that it's not 28%. So this is an example of where you're going to use not equal to. So I wanted to do this problem to show you, all right, that tomorrow it might be not equal to. Right? Remember, you have 3 options. Your alternative is going to be less than, greater than, or not equal to. One of those 3 options. Okay, so let me make sure we're all understanding since I messed this up. It's my apologies. So, all right, this is like number 1, doing this first. Okay, the parameter. Number 2 is hypotheses. That's the second thing. And then the third thing is the model, your assumptions and conditions. All right, so make sure you organize that correctly. That's my fault. When you look at the key for this later, if you want to check Classroom when I post this, it'll be in that order. Okay? I'm not going to be that much of a stickler, but yeah, I mean, in theory, I messed up because I'm talking about P, right? And I used it, but I didn't say what it is. All right, everybody good so far? Okay, so let's move on to the mechanics. All right, so this would be step 4. Okay, so this is where you're going to do your math. All right, so how many women 40 or older did they survey? 500. How many said that, yes, I get a regularly scheduled mammogram? Is it 151? Yes. Thank you. So your P hat is going to be 151 over 500. 302? Anyone confirm your F?
Yes.
302? Okay. Okay, so now you would move to looking at the formulas that I'm going to show you tomorrow. All right, the formula is z-score equals p hat minus p over the standard deviation of p. And the standard deviation of your population proportion is the square root of p times q over n. Okay. So we're going to substitute some numbers in here. We just calculated p hat, right? P hat was this fraction here, so 0.302 divided by the square root of 0.28 times 0.72 over 500. I didn't finish the numerator. Geez, Douglas, my bad. Man, I'm really struggling today. Sorry, I forgot to finish the numerator. Minus p, your population proportion, and then the denominator. All right, and at this point, right, as I told you guys yesterday, you can move to your Chromebook or your phone. All right, because when you do this on MathCracker, it will give you the z-score and the p-value. All right, but if you wanted to use the yellow calculator, it will be available to you. If you want to do this in the yellow calculator, that's fine. Okay, so let's move to MathCracker. Yes, Catherine. It should be an option. Is it an option when you click it, the dialog box? Let's check. Let me get MathCracker going. Crack this math. What's up? Oh, not for me. Okay, sorry. Okay, so the null is always equal to, right? This is always going to be equal to. And then there should be an option. I have the option. The first one is not equal to. You just clicked the wrong. I think you might have been on the null. Okay. All right. What is our p? 0.28, right? Our population proportion, 0.28. So what's interesting here, Charlize, is that we don't actually tell MathCracker what p hat is, even though we used it when we wrote in the problem. They're going to calculate it for you in the when you hit solve. Okay, so they sampled 500 women, and I believe it was 151 women said yes, regularly scheduled mammograms. And what did I tell you guys for alpha? 0.05 until we talk next week. Well, next week I'll give you the choice of how you want to proceed. You can always use 0.05. I'm going to talk to you next week about the relationship between what you choose and how that affects how good your test is. All right? So I'm going to hit solve. Takes a while. I'm going to be patient, though. Stay with us at home if you're watching. You can watch this person cut some wood. Commercial break. I like it. DIY wood.
They're not paying you. You gotta remove that.
Oh, now we can go to the Olive Garden while we wait. Perfect. Everyone loves their breadsticks. Let's be honest. And are they doing the Never End of Pasta Bowl? Because man, those are the best. Oh, look, it came. There we go. Okay. So as I said, Charlize, it'll give you p hat, like almost right at the beginning, 0.302. It gives you the hypotheses, but at this point, right, you've already written down your hypotheses. Now, one thing I want to point out to you is that it does say it's a two-tailed test. Okay? You all right? Okay. So when I draw my curve, well, I guess I should write my z-score first. What's the z-score? 1.096. When I draw my curve, and this is different because we haven't done a two-tailed test yet, but when you look at 1.096, because you're doing both tails, right, not equal to, you actually have to draw one for negative 1.096 as well, and you shade both directions. Well, I'll get to that soon, Ureth. Right now, all we care about is alpha is 0.05, because tomorrow on my quiz, I'm not going to require that you do a confidence interval at the end. Okay, so you don't have to worry about that. We're going to talk more about what your brain just asked about on Tuesday and Wednesday of next week, because I only see you 2 days next week. 2 days, yes, because you work Monday,
No school Thursday.
then you don't have school Thursday
And
for some reason, and then you work Friday. So I only see you for 2 days. Right, Guillermo? Okay.
The juniors work at
So the p-value, if I look at my MathCracker, the p-value, was that a number 4?
Yeah.
Yeah. The p-value is 0.2732. So point
And it says it's greater than 8.5. That's our.
0.05. Yeah, so you always compare your p-value to your alpha. All right. Remember, if your alpha, right, your alpha is, I guess I should do a p-value. If your p-value is not below alpha, then you don't have enough evidence to reject. And that's what the conclusion on MathCracker is saying.
That you do not.
It's not rejected. You fail to reject the null. All right.
It says 0.5 on that.
Should say, did you type in 0.5? Because it should say 0.05. Yeah.
Oh, okay, good.
Yeah. And you can use an alpha of 0.05, right? But we're going to talk on Tuesday and Wednesday about how then the power of your test will not be as strong, right? Because basically what you're saying, use 0.5 right in the middle of the room, you've got a lot of p-values that you'll end up rejecting. All right. So when you reject at 0.5, you're going to be not very confident that you made the right decision. But if you reject way down here, right? If I say, here's my bar, it's got to be below this, then I'm going to be pretty confident that when I'm rejecting, I feel good about what I'm doing. Okay, so here we go. Let's write the statement. All right. With a p-value above my alpha, I am going to fail to reject the null hypothesis. Now, I think, Saul, you asked yesterday, can you just say, I'm not going to reject? That's fine. Okay? I just want to use that phrase because it's going to help you with, like, later on questions. But if you want to write, I'm not going to reject the null hypothesis, I will accept it. Okay? Well, in the stats world, we call this is linkage, right? Your brain needs to link the decision for the p-value compared to alpha with your conclusion. All right, so I'm going to be looking for that on tomorrow's quiz. Like, cause let's say you mess up the p-value, right? Let's say you're doing this problem and you get a p-value of 0.007. That's below alpha, so you should conclude that there is enough evidence to reject the null hypothesis. So I would still give you credit for making the right decision, even though you got the wrong p-value. Right, you'll get points off for the wrong p-value, but I'm not going to like double hit you because you made the right decision based on your results. All right. Same thing if you accidentally do an alpha of 0.5, your decision would be different. All right. So I'm going to hit you for the 0.5. I probably actually wouldn't because I just like, Charles, did you really want 0.5? No. But ultimately, right, I'm going to read everything and decide what you did. All right. Did you make the right decision? Okay. So we're almost done. I'm sorry, Travis. I'm almost done. And then yes, there's one more sentence I need to see. All right, because this has no context. Right? There is not enough evidence. Okay.
That the proportion of all women scheduled of all women over 40 scheduled for mammogram is greater than.
So you would put is not
It's not.
28%, because remember we're doing like not equal to, so you'd put is not. Watch how I write it, Ureth. You can choose, I don't care which way. There's not enough evidence to dispute the claim that 28% of women aged 40 or older get regularly scheduled mammograms. All right, so you can do it this way, or as Ureth said, right, she's choosing to phrase it a little differently, totally fine. Okay, and I'm just looking for this stuff to match up, guys. All right, so this is the context to my decision in the sentence before. Okay, tomorrow.